What's up guys, Patrick here, welcome back. Moving on to the next example. So we got the limit as x approaches 0 of x squared times the ln of x squared. So like usual, first thing you want to do is a direct substitution, see what's happening with the function. So notice we got two functions multiplying by each other, x squared times ln of x squared. If we plug in 0 here, notice it's going to go towards 0. Now, if we plug in 0 over here, we can't take ln of 0. Remember, this ln of something, that expression always has to be positive, can't be 0 or negative. But ln of x squared, the way it looks like, is it looks like this. Right? So notice that as we approach 0, ln of x squared is actually going to approach negative infinity, right? Because this is going to be a very small positive number, because if we approach 0 from the negative side or from the positive side, the fact that we're squaring it is going to turn it positive, and then ln of a very small positive number, ln just in general looks like this. So ln of a very small positive number is going towards negative infinity. So this function is going towards negative infinity. Now I want to make a note that we were able to write the limit as x approaches 0 because this was x squared here. Now if this was just x, so if we had the limit as x approaches 0, let's say of x squared times ln of x instead of x squared, we'd actually have to approach the 0 from the positive side, right? Because from the negative side, this is negative x values are not in the domain of this function. So we'd have to approach x from an x value of 0 from the positive side, but the fact that it was x squared, we were able to just write 0. You could also write this as negative or positive, but we were able to write it as that general limit because of this x squared here. So anyway, not as big of a deal, but thought I would mention it because a lot of times you'll have ln of x in these questions and you'll be approaching 0 from the positive side. And the reason why is because ln of x is not defined for negative values. All right, so when we do a direct substitution here, this here, notice it's an indeterminate product. So what we got to do is convert it to an indeterminate quotient and then see if we could apply L'Hopital's rule on that. Now, do we want to bring the ln of x squared down and the reciprocal of that, or do we want to bring the x squared down? Well, I feel like if we bring the x squared down, it's going to be better because we're going to have the limit as x approaches 0 of ln of x squared over 1 over x squared. Right, so this function and this function are the exact same thing. And now notice that when we do a direct substitution on this, we know this is going towards negative infinity. And then this here is going to go towards positive infinity. 1 over a very small positive number is going to be positive infinity. And negative infinity over positive infinity, that's an indeterminate quotient. Right? The signs can be different. It doesn't have to be negative infinity over negative infinity or positive infinity over positive infinity. The signs can mix, but it's got to be infinity. So this is an indeterminate form here. So we can apply L'Hopital's rule on this. So what we would do is we would take the limit as x approaches 0. We would take the derivative of the numerator. Now ln of x squared, the derivative of that is going to be 1 over x squared times 2x, right? If we got ln of a function, the derivative of this is going to be 1 over that function times the derivative of that function. Apply the chain rule. That's what we did over here. And then the derivative of 1 over x squared, that's like x to the negative 2. Apply the power rule on that, negative 2x to the negative 3. Which is like negative 2 over x to the 3. Right, so the derivative of this is this, the derivative of this is this over here. And now what you want to do is just do some algebra and try to simplify this. So notice that, let's continue over here. This bracket will have the limit as x approaches 0, This bracket here would simplify to 2 over x. Like that, yeah. 2x over x squared is 2 over x. And then we'd be dividing by negative 2 over x to the 3. We can't simplify this, but dividing by a fraction is like multiplying by the reciprocal of that fraction. And then this here we can simplify. Notice the 2 divided by negative 2, that's just going to be negative 1, right? 2 divided by negative 2 is negative 1, and then x to the 3 divided by x, that's just x to the 2. And then the limit as x approaches 0 of this here, of negative x squared, we could do a direct substitution. It's equal to 0. Okay, so this limit here is 0, right? So took the indeterminate product, converted it to an indeterminate quotient, applied L'Hopital's rule, did some simplifying, some algebra, 0 is the final answer.